Good day. Welcome back to our channel. If you're new here, welcome. My name is Tifla, and today we are going to deal with 2D 3D, the third lesson, which is on cosine rule. So firstly, we have to prove this cosine rule that says that a squared is equivalent to b squared plus c squared minus 2 multiplied by b multiplied by c multiplied by the cos of angle A, right? So obviously, before proving, we have to construct. So let's see how everything goes back. So this is what we're trying to prove right there. So we're trying to prove that this side squared is equals to this side b squared plus this side c squared minus 2, these two sides being multiplied, and then cos of this angle A, right? So let's just see. So how do you construct? So first we said we need to construct. So what are we constructing? We are constructing this line C to line from angle C to line AB, and it must be perpendicular. So this is perpendicular right there. So we are constructing line from C that is perpendicular to A, B, like that, right? So this line we must call it line H, the perpendicular height. So this is our H, our perpendicular height, right? So now how do we prove now? So it means that we are going to prove in these two triangles that we constructed, this triangle and this triangle, right? So now this line, since this line AB is equivalent to C, so let's introduce a variable from this point to this point. So from this point to this point, let's call this line X. So we've introduced that and we call that line X. So it means that this line now from this point up to B, since this whole line, it is line C and this is X. So it means that this must be C minus X. So to move from this point up to B must be giving us C minus X, like that, right? So now let's begin with our proof. So as I said, we are proving into this triangle and this other triangle, right? So now in this triangle that is having A and C, we can see that our B squared, since this is 90 degrees, so it means that our B squared is equivalent to A squared plus X squared, taken from theorem of Pythagoras. So it means that our B squared is equals to H squared plus X squared. So this is from the theorem of Pythagoras, right? So what else? So it means that we can make H subject of the formula. So it means that our H now, A squared, becomes our B squared minus our X squared. So it means that we took our X squared to that other side, and here we're remaining with A squared. So we can call this our equation number 1, like that, right? So let's go on with our proof. So we know that we're having this equation there, so let's not forget about this equation that we made. Now let's move to this other triangle now. So you can see that in this triangle we're having A squared being equivalent to A squared plus C minus X squared, because also this is a right angle triangle, so we can also use the theorem of Pythagoras there. So we can also write our a squared is equivalent to our a squared plus our c minus x all squared. And again, we can make our h squared subject of the formula. So it means that our h squared becomes our a squared minus our c minus x squared, like that. So this is also from the theorem of Pythagoras. From the theorem of Pythagoras. So let's see now. We can see that we can expand this, right, using the product. So let's just try to expand that on the side so that we can insert that. So that is saying c minus x squared. So if we multiply out these brackets, we are going to have c squared minus 2c multiplied by x, and then plus x squared. So this is what is given by this bracket here. It is giving us that. So let's just replace that. So it means that our h squared now becomes our a squared minus our c squared minus 2cx squared plus x squared, like that. So now this definitely means that our a squared is equivalent to our a squared minus c squared plus 2c x, sorry, this is not a squared, and then minus our x squared. So this whole thing is coming from this, right? So a squared minus c squared plus 2cx minus x squared. So now this we can call it our equation number 2 right there. So now we're having this equation that is saying a squared is equivalent to b squared minus x squared. So these two equations, we can see that a squared and s squared, and since our h is the same, so it means that we can equate these two equations, right? We can just equate these two equations. So let's just do something like that. So we can see that our equation number 1 is equivalent to our equation number 2. So this is saying a squared minus c squared plus 2cx minus x squared. And this should be equivalent to equation number 1, which is saying b squared minus x squared. So b squared minus x squared. So this is equivalent to b squared minus x squared. But you can see that on both sides of the equation we are having minus x squared, so it means that we can cancel that out, minus x squared minus x squared. So now we are left with our a squared minus c squared plus 2cx being equivalent to b squared. So we can take all this to the other side because we need a squared this side. So our a squared now becomes b squared, and this going to that other side, it will be positive, so plus c squared and then minus 2c and x. But since x is the variable that we introduced, so let's try to find the value of c squared of c using whatever that we're having. So in this triangle we can see that we are having this value as our value of x, right? But here we are having angle A, so we can try to find our x using the angle of A. But again, we know that our cos of our angle A is equivalent to adjacent over the hypotenuse, right? So our adjacent is x, so this is equivalent to x over our b. So let's make our x subject of the formula. So it means that our x now becomes b multiplied by cos of angle A. So it means that we can try to put that x as this, right, on the equation that we are having below there, right? So we said our x is equivalent to our b multiplied by cos of angle A. So it means that we are going to replace this x by that. So it means now that our A squared becomes b squared plus c squared minus 2 multiplied by c multiplied by b multiplied by the cos of angle A, which you can rearrange as our A squared equivalent to b squared plus c squared minus 2b c and then cos of angle A, just like that. So we have proven what we're trying to prove, that in any triangle our A squared is equivalent to that. Our A squared is equivalent to that. So this is the cosine rule. So how does the cosine rule work now? Let's just see how it works. So this works in this way. So we proved above that our A squared is equivalent to our B squared plus C squared minus 2BC cos of angle A. So it means that whenever that you are trying to find this side A, it means that you must have an included angle A and these two sides. So it means that this, for this to work, you need 3 sides and 1 angle. So it is 3 sides and 1 angle. Just know that this side that you're trying to find must be opposite to the angle that you are already having, like that. And again, if you are having different things, maybe you're having angle B and you're trying to find side B as well. So it means that our B squared will be equivalent to our A squared plus our C squared minus 2AC and then cos of angle B. So whatever side that you're trying to find must be opposite to the angle that you are already having. And just a similar thing, it means that also if you're trying to find this side C and you're having this angle C, so we can also say our C squared is equivalent to our A squared plus our B squared minus 2AB and then the cos of this angle C, like that. But also remember that sometimes you can be given 3 sides trying to find the angle, or you can be given 2 sides and 1 angle trying to find a side. So whatever the situation, if you're trying to find the angle now, just make sure that that angle that you're trying to find, you must start with the side that is opposite to that angle. As simple as that. So in the next session, we're just going to solve the questions regarding the cosine rule. If you haven't subscribed, please subscribe, like, and also comment what you think we can do better on our next session. Besides that, have a lovely day.